So in this video we want to begin to review the solving of quadratic equations. Now there's quite a few methods we use for solving quadratic equations, but generally speaking using the null factor law is one of our first ports of call. We'll get to that however because for me there is a step before that that you want to think through. Okay, you don't want to automatically go for trying to factorize and use the null factor law, because if the equation can simply be solved by rearrangement, that's actually your ultimate option. What I mean by that is if the equation only has x in one place, like this one does and like this one does, then we should be able to just use simple, year 7 and 8 equation solving techniques, which is to do the same thing to both sides until we get x on its own. And we don't need any special quadratic techniques. So for example, in example 1a here, we're trying to get that x on its own. X has been squared, then multiplied by 2, then 9 has been subtracted. So to solve it, the first thing we want to do is add 9 to both sides to try and get x on its own. Then to divide both sides by 2, and then to take the square root, bearing in mind that when we take the square root, we get plus or minus square root of 9 on 2. Now 9 is a perfect square, so I'm going to take the square root of the numerator, that's plus or minus 3 on root 2. Now that's perfectly fine. In methods we don't need to give answers with rational denominators, but if you rationalise the denominator there by multiplying the top and the bottom by root 2, we could also write that answer as plus or minus 3 root 2 on 2. Either of these, this or this would be perfectly fine. Okay. Part B, again focusing on what's happening to x. So x, the first thing happening is 1 is being subtracted, then it gets squared, then it gets multiplied by 4, then 7 is subtracted. So the first thing we need to undo is the subtraction of 7, so we're going to add 7 to both sides. Then we want to undo the multiply by 4, so we're going to divide both sides by 4. If you were to try and take the square root at this point, the issue you would have here, the mistake students would make is they would go, it's 4 times x minus 1 equals plus minus root 7. And I'd say, well, okay, you've taken the square root of that, you've taken the square root of that, but what happened here? And this is what happens if you go out of order. So if you understand your order of operations, your BODMAS, you understand how the expression was built up, and then you undo it in the reverse order, you won't have any problems. The minute you go out of order, you can do it, it's possible, but you would have to square root everything. So you need to be a bit careful, and then you get mixed up about plus minuses and where do they go and how many are they. So stick to the right order. Divide by 4 next. So this is 7 on 4. Then we take the square root, okay, which is plus minus root 7 on 2, because 4 is a perfect square, and then we can add 1. So x is plus or minus, so I might write the 1 first, 1 plus or minus root 7, 7 on 2. When you're writing surds, be careful, like so here where I mean it's the square root of the whole thing, okay, don't get slack about, and then is that in the square root or isn't it, be really clear about what you mean. Similarly here where I don't mean the square root of 7 on 2, again, don't be ambiguous about, okay, I've sort of got that is what's happening here. Try and make sure that the easiest way to do that is make sure that your vinculum, the line that divides the fraction, really cuts off the square root. There's no possibility that that square root is extending down past there. Okay? So again, careful. We need to be really careful. This is a really precise subject. You make errors with notation, you slightly write things in the wrong way, you don't extend your vinculum long enough, you leave out a bracket, it says something different. And it's really important that you understand that and that you're really careful about how you write things. Okay? You could get a common denominator here and write this is 2 plus or minus root 7 all over 2, but there's no reason to do that. Okay, so if you can solve by rearrangement, that is, if there's just one x in the equation, then you want to do that. If not, our next step is to try and use the null factor law. And the null factor law states that if you are multiplying two things together, i.e. a times b, and they equal 0, the only way that happens is if a equals 0 or b equals 0. Now when we use OR in maths, it's always an inclusive OR, so that implicitly means and OR. So yeah, they could both equal 0, that's fine. That's included in the word OR. So to use the null factor law to solve an equation, a quadratic equation in this instance, the equation must first be written as a product of things equal to 0. So when we're using it to solve a quadratic, we want to first of all make one side equal to 0. So we've got the null part of the null factor law. So we're going to get it to look something like this. Might not have all the terms, but that's fine. And then we want to factorize the quadratic expression, because when we do that, when we factorize something, we are writing it as things that are multiplying together. Okay? Bracket times a bracket equals 0. And then that means either this bracket equals 0 or this bracket equals 0. Okay, so let's use our null factor law to solve. So x squared plus 2x minus 48 equals 0. We want to make one side equals 0. That's already done. We want to factorize the other side. So we want to factorize the left-hand side. It's a simple monic quadratic. Go back to the previous video for a review on factorization. So we're looking for factors of negative 48 that add up to positive 2. 48 is 6/8, so they're going to have a difference of 2, so we just need to work out where the negative goes. So it's going to need to be plus 8 and minus 6 for them to add up to positive 2. Please don't ignore the equal to 0. Okay, it's a real pet peeve of mine when students frequently just leave it off here, and then they say that x equals negative 8, x equals 6. The only way that x equals negative 8 and x equals 6 from that previous line is because that equals 0. That's the whole point about the null factor law. You've got two things multiplying together to equal 0, which means either x plus 8 equals 0, which means x equals negative 8, or x minus 6 equals 0, which means x equals 6. Now, when you're solving quadratics, and you've done this for a while, yes, I'm perfectly happy for you to go straight from this line here to saying x equals negative 8, x equals 6. But I find if you make mistakes when it's things like this, and you try and tell me that this means that x equals negative 1, or you accidentally get jumbled around with how to solve that, take the time about how to do it properly. But equally, I'm also trying to help you maintain a connection to what it is that you're actually doing, because the null factor law isn't just for quadratics. Down the track in year 12, when we've maybe got an equation like e to the x times sine x equals 0, the null factor law also applies. We are multiplying together two things to equal to 0, which means either that thing equals 0 or that thing equals 0, and then I can focus on solving those two separate things. Okay, so it's really important that you don't lose track of what is the maths behind you actually writing down that and that. Okay, and I think too many people, when they go straight from that step to that step, just learn it as, oh, I just write the opposite of that number. Okay, and that's where then they make mistakes. If it's 4x minus 8, they write x equals 8. Well, it's not the opposite of that number, because this 4 is also part of it. So you've got to be able to think clearly about what it is that you're doing, so that those things that we're learning now are then going to be able to be extended into harder things down the track. Okay, part B. So we've got our two solutions here. We're done. Part B, we want to first of all make sure we've got one side equal to 0. So let's write this as x times x minus 4 minus 5 equals 0. And then we want to factorize the other side. Now these bits are factorized, but the whole left-hand side isn't factorized. It needs to be something times something equals 0, so that we can use the null factor law. And this is something times something minus 5 equals 0. So it doesn't mean that x equals 0 or x minus 4 equals 0, because that doesn't equal 0, that equals 5. Okay. It's also not appropriate. Some people might be tempted to go, oh, that means x equals 5 or x minus 4 equals 5. That doesn't apply, because if we know that two things multiply together to equal 5, that doesn't tell us that that has to be 5 or that has to be 5, whereas when it's 0, it does tell us that those things have to be 0. Okay, so what we actually need to do here is expand out the left-hand side so that we can then properly factorize it. So this is x squared minus 4x minus 5 equals 0. Now we've got a simple quadratic that we can factorize. We're looking for factors of negative 5 that add up to negative 4. So that's going to be minus 5 and plus 1. So there's our fully factorized. So now that we've fully factorized, these two brackets multiply together to equal 0. Either this bracket equals 0, which means that x equals 5, or this bracket equals 0, which means that x equals negative 1. Okay, part C. Again, let's get one side equal to 0. 2x squared plus 12x plus 18 equals 0. Now it looks like a non-monic quadratic, but remember our first step of factorization is to look for common factors. There's a nice common factor of 2 here. Because it's an equation equal to 0, we don't have to factor out the 2, we can just divide everything by 2. So it's x squared plus 6x plus 9 equals 0. Factors of 9 that add up to 6 are 3 and 3, so this is actually a perfect square. It's x plus 3 all squared. This actually can be solved by rearrangement. Square rooting both sides, square root of 0 is 0, so x plus 3 equals 0. So x equals negative 3, so there's just one solution to that quadratic equation. Okay, part D, we've got an equation with fractions. If you go back to the early videos on solving linear equations involving fractions, the first thing we want to do is get rid of the fractions. Now you might be able to do that in one step, but remember our fail-safe method if we get a bit stuck or we tend to make mistakes here, is to write every term with a common denominator. Now at the moment the denominators are 1 and x, so the common denominator is x. Okay, so this first term was 5 over 1. We've multiplied the denominator by x, so we do the same to the numerator. This second term was 2x over 1, negative 2x over 1, sorry. So we multiplied the denominator by x, so we do the same to the numerator. Now we've got a common denominator, we can multiply everything by x, and we're left with 5x plus 3 equals negative 2x. Negative 2x squared. Let's add the negative 2x squared onto both sides, so we get 2x squared plus 5x plus 3 equals 0. Now we can factorize. We've got our null component. We want our factors on the left-hand side. So it's a non-monic quadratic. There's no common factors. So harder factorization method. 2 times 3 is 6. Factors of positive 6 that add up to positive 5 are 2 and 3. So that is 2x squared plus 2x plus 3x. So splitting up that 5x using these two numbers. And then the plus 3. And then we want to group. Common factors in the first two terms are 2x, leaves us with x plus 1. Common factors in the second two terms are 3, leaves us with x plus 1. So it is x plus 1 times 2x plus 3, taking out that common factor of x plus 1. And then our null factor law tells us that either x plus 1 equals 0, which means x equals negative 1, or 2x plus 3 equals 0, which means 2x equals negative 3, which means x equals negative 3 on 2. Okay, example 3, final example here is a worded problem, and it is taken from your textbook, exercise 3C, question 13. The members of a club hire a bus for $2,100. 7 members withdraw from the club, and the remaining members have to pay $10 more each to cover the cost. How many members originally agreed to go on the bus? Okay, so originally, and after 7 withdrew. Okay, so let's say, I'm just going to move that over. I'm going to set myself up a bit of a table here like I do for distance, speed, time problems. Okay, so let's have number of members, total cost, cost per person. Okay, so originally, let's say there was originally X members, that's what we want to find. After 7 withdrew, there's obviously X minus 7 members. The total cost is still 2,100 both times. And so the cost per member originally was 2,100 divided by X. The cost per member after 7 withdrew is now, 2,100 divided by X minus 7. Okay, so we know that this new cost is $10 more than the original cost. So there's our equation. 2,100 on X, the original cost, plus $10 is the new cost. Okay, it's an equation involving fractions. Let's focus on common denominator. This is going to be an ugly line, but it's worth it to get things right, and then it'll be simple after that. So the denominators are x1 and x minus 7. So x times x minus 7 is the common denominator. We're going to write everything with that. Oops, x times x minus 7. So the first fraction we've multiplied by x minus 7. So we'll do the same to the numerator. The second fraction we've multiplied by both x and x minus 7. So 10x times x minus 7. And the third fraction, we've just multiplied the denominator by x. So now we can drop the denominators because we multiply everything by x times x minus 7, and we get 2,100 times x minus 7 plus 10x times x minus 7 equals 2,100x. And then we can expand out and collect some like terms. I think it'll tidy up fairly nicely. So 2,100x minus, okay, so 7 lots of 2,000 is 14,000, and 7 lots of 100 is 700, so it's going to be 14,700. Plus 10x squared minus 70x equals 2,100x. Okay, subtracting 2,100x from both sides, those are going to cancel out. Let's see what we've got left. I'm going to write it in order too. We've got 10x squared minus 70x minus 14,700 equals 0. Okay, 10 is definitely a common factor. X squared minus 7x minus 1470 equals 0. Okay, now I'm going to admit that this isn't an easy factorization by hand. Okay, yes, it's a simple quadratic, and once we work out what the factors of 1,470 that add up to, sorry, negative 1,470 that add up to negative 7 are, then we'll be able to write down our answer straight away. But the number work here is a bit tricky. However, this is where we want to be able to think about, we actually can think about, we know that 2,100 multiplied by 7 was how we got 14,700. Which means that 210 times 7 is 1470. So let's start with that. Okay, it's really important that you can actually work through this. Okay, 1470. So I know my starting point, you just need to know one multiplication. 210 times 7 gives me that. Okay, so then we can go from here. Okay, so 210 is 30 times 7, or 3 times 70, for example. Okay, and that's 10 times 3, and that's 2 times 5, right? So essentially, prime factors, it's 2 times 5 times 3 times 7 squared. Okay, so we want to work out, we can group these together. So for example, we can say it's 10 times 3 lots of 49. It's 15 times 2 lots of 49, 98. Okay. So you can work with those combinations until you get, in fact, 7 squared is not that helpful because we can split that up. So it's 21 times 2 5s are 10 times 7 times 70. Okay. So we're looking for a combination of numbers that have a difference of 7. So maybe 5 times 7 is 35, and that leaves me with 6 times 7, which is 42. There we go. So 35 times 42. Alright, one has to be negative to multiply to give negative 1470, okay? And obviously we want the difference to be negative 7, so if it's minus 42 and plus 35, that's where we are. So you can work from that one pair of factors, okay? You can either break it fully down into the prime factorization and then look at grouping those together until you get two numbers that work, or you could have gone from the 1470 210 and 7 and said, okay, well, if I divide this number by 3, that gives me 70, times this by 3, it's 70 times 21. Okay. If I then divide this by 2, that's 35, times this by 2, that's 42. Again, you might have taken you a while. Divide that by 7, that's 30, times that by 7, that's 49. But start building up pairs of numbers. So, as I said, if you divide that number by 2, you have to multiply, sorry, we divided by 3. You have to multiply that number by 3 so that they still multiply together to give the same value. And you can gradually just work on different pairs until you get the one that works. You know, again, it's about that. I talked about back in the constructing linear equations. It's about not just always expecting to be able to look at the answer and come up with it. You might have to work through it a bit. You might have to write some things down. That's okay. You need to be able to do that though. Okay. Alright, so then our null factor law tells us that x minus 42 equals 0, so x equals 42, or x plus 35 equals 0, so x equals negative 35. But x is the number of members, so x has to be positive. So x equals 42. Therefore, originally 42 members agreed to go on the bus. that was the question. How many members originally agreed to go on the bus? Yep, don't be ambiguous about answering the question. Make sure that you've answered it. Okay, so exercise 3C, a mixture of solving just equations, but I think there's also some worded equations in there for you to have a go at. So some good practice to be had there.